A very good morning, good afternoon, or indeed good evening, wherever in the world you happen to be, and welcome to this webinar, which takes fuel cells, key operational challenges as its theme. The webinar is part of Riviera's Maritime Hybrid, Electric and Fuel Cells Webinar Week, and will be 45 minutes in duration. Before we start, I'd like to share with you some key information that will support you in getting the most out of today's webinar. After the broadcast, we will send you the recording. Please do submit your questions at any time because we will do Q&A throughout the webinar, and any questions that we don't get to, we will come back to you in writing 1 week after transmission. Please stay tuned in to the end so you don't miss out, and at the end, please complete the exit survey, and in turn, we'll send you the presentations. Time to introduce your hosts, Riviera Maritime Media. Riviera is a maritime and offshore information specialist active in 4 business areas: news, events, jobs, and data. To learn more, please visit the dedicated website www.rivieram.com. Time I introduce myself, I'm Edwin Lampert, Head of Content at Riviera Maritime Media, and I'll be moderating proceedings today. Let's now take a look at today's agenda. We'll variously consider the status of land-based supporting infrastructure and challenges, the operational and maintenance costs of hydrogen fuel cells, potential CapEx and OpEx costs, the green agenda and the impact of recent events on funding for research and development projects, and also the future of hydrogen fuel cells. Let me now share with you the running order, or in other words, how it's going to go. Presentations will be run consecutively and followed by open discussions. Please do submit your questions at any time because we will do Q&A throughout the webinar. At the end, we'll share key takeaways and conclusions, and we'll also preview what's next. Time to meet our panelists. I'm delighted that we have Joseph W. Pratt, CEO and CTO with Golden Gate Zero Emission Marine. Next up and on the line, we have Chalva Magnussen Svensson, who is a researcher with Prototech. And completing our lineup is Christina Julsgaard. She is Business Development Director with Ballard Power Systems Europe. During the next 45 minutes, we'll find time for a poll or two. And as you know, at any time, please submit your questions via the webinar messenger. So more than enough from myself. It's time we come to the panelists. First up, I'm delighted to say will be Joe. So as and when you're ready, Joe, the floor, as they say, will be yours.
Great, thank you, Edwin. Thanks for inviting me to today's webinar. By a quick introduction, my name is Joe Pratt, and I've been working in the hydrogen and fuel cell space started actually over about 20 years ago. Currently CEO and CTO of Golden Gate Zero Emission Marine. We are right now building North America's first hydrogen fuel cell ferry. That's the picture shown on the cover page here, called the Water Go Round. So I'm happy to talk about real quickly some of the key operational aspects that we've seen over the last few years of being in business and selling marine powertrains. When we talk to folks who are interested or potentially interested in hydrogen fuel cell power for their vessels, we typically encounter 3 or 4 questions that they're trying to evaluate to see if the technology is going to work for them. The first one, to be honest, usually we don't get this question because by the time people ask or have wondered if the technology works, that groundwork has already been laid by everybody who's working in the hydrogen fuel cell space. So someone who comes to us either believes that technology already works or has an open mind to understand about it and trusts us with what we can offer that it does. The performance requirements and arrangement limitations is always a really important question. I'm not going to cover that today, although there are many insights there that we've learned over the years. But I believe that was covered in yesterday's webinar, so people can refer to that one for some of those aspects, or bring them up after this, and I'm happy to go into some more detail there. The two I'm going to cover today in a very limited fashion is the cost and the hydrogen availability. So these two, I would say around 50-50 come up as the most important concern to resolve before people are willing to adopt these technologies on a vessel. So I'm going to start with the cost side. There are several aspects of cost, and here I'm really just focusing on the operating cost. Because for an application like marine, which is operating really heavy duty cycles, the operating costs can be at least over 90% of the total cost of ownership. And much of that cost has to do with the fuel. And then secondly, with the maintenance of the fuel cells because they get so many hours on them. So the operating cost, it depends on the cost reductions that we're seeing in the market with fuel cells and with hydrogen. And if you start penciling those out and looking into the future with some of the projections of both of these components, and there are a lot of reasons for these cost reductions that we're seeing, then you get the chart on the right, which is a little bit busy, but what it shows is that there are certain types of vessels that are cost effective at different times. And this relates to the size of the power plant, the usage of fuel, and other factors. So here you can see, for example, that passenger vessels, we've found there are many types of passenger vessels today that are cost effective right now. In other words, cheaper than diesel to operate. Next up quickly would be tugboats, and then getting into some of the lighter usage, actually, the fishing boats and yachts, and then the very heavy usage, cruise and cargo ships. So that's just a real quick snapshot of how we see the cost playing into this. And for us, one of our early markets is in the passenger vessels and tugs, partly because of this reason. And the other important factor is hydrogen. So where do I get the hydrogen? Some people have told us, you know, we're interested in the technology, but we don't want to move forward at all until you can tell us we can get sufficient hydrogen. So I'm going to focus only on one aspect of that. I believe Chalve is going to talk a little bit more about availability of hydrogen and those aspects. But the part I want to focus on is liquid hydrogen. And liquid hydrogen is important because it's much denser, much more compact than gaseous hydrogen storage. What this means is it enables many different kinds of vessels to adopt hydrogen fuel cell technology. The large ships, for example, just can't be powered with gaseous hydrogen. There's simply not enough room on board. So until we can provide enough liquid hydrogen around the world, we're going to be severely limited in the applications that hydrogen fuel cells can support. Right now in North America, we're pretty lucky because of the liquid hydrogen infrastructure that's been developed to support the space program. But this numbers needs to change around the world. We've got to be developing more liquefaction facilities in order to support this. And in our experience, there are projects being started, being considered all around the world. So this is happening, and the usage of a single vessel is in some cases enough to justify the building out of a new liquid hydrogen infrastructure in a region. So again, these are just a few real quick hits on some of the aspects of the key operational challenges that we see. I just touched briefly on them. I'm happy to explore these in more detail in the Q&A, and also any other questions that you have on the key operational challenges of hydrogen fuel cells for marine vessels. Thank you, and back to you, Edwin.
Thank you very much indeed. Fantastic job, and testament to that is the number of questions you've generated. Ladies and gentlemen, please do keep those questions coming. As you know, we get to as many of them as we possibly can. Now, joining us on the line is Chalve. So Chalve, as and when you're ready, good sir, the floor is yours.
Yes, thanks a lot, Edwin, and thanks everyone for listening in. So today I will first say what I believe is the key operational challenges of implementing fuel cell technologies in the maritime sector. Before I will say a couple of words about the company I represent, Prototech, and our approach to mitigating these challenges, and something about ongoing projects. So as you hopefully can see on my screen now, what we should really be focusing on is the fuel availability and the fuel cost. That is the most critical barrier, as also Joe came into in the last presentation. There are, of course, other aspects as well, such as the size and weight of the systems, the durability, efficiency, approval process and legislation, and also the cost of the fuel cell systems. But I see those matters more as things that can be certainly improved over the years, but there are no really showstoppers at all. So what we should be focusing on is the fuel cost. If we do simple calculations, looking at the lifetime cost of the fuel cell systems versus the fuel systems, as you hopefully can see on the figure on the right, it's often a 10 to 90% difference, as Joe also said. So really, we should be focusing on developing the value chain and also the bunkering and logistics. And I think, the fuel availability for these first demonstrations and early market introduction of this technology, this is really the key issue, because you also have to pay for the bunkering systems. And I think we need to acknowledge the time it takes to establish this complete value chain for new fuels. So it has taken about 20 years since the first LNG vessel till only today we have logistics so that we can enable the first cruise vessels operating on LNG as such. So I believe that if we are actually going to meet these IMO targets and to realize a zero carbon maritime sector, which obviously we have to aim for, I think we need to promote and highlight and build up at a reasonable pace different technologies that can enable zero emission shipping. So hydrogen and low temperature fuel cells, ammonia, which is another hydrogen carrier, and high temperature fuel cells, and even also LNG and other carbon fuels. But I think we also need solutions where we can have carbon capture on board the vessel. So two words about Prototech. We're not the typical fuel cell supplier, but we're more a technology development company owned by a research institute in Bergen in Norway. And we are involved in a large variety of both technologies and applications. And we've been working since the beginning with such a space application, which is really demanding. And I think that is necessary going into being able to develop the solutions that we need for the maritime sector. So, and nevertheless, we have also been working for a long time with hydrogen technologies, fuel cells, and electrolyzer technologies, and also very broad, a lot of different technologies, and with a focus on compactness. So starting with developing what was probably the first combined heat and power system using high temperature solid oxide fuel cells. And we also have hands-on experience with a small vessel where we had a hydrogen fuel cell system on 10 years ago. So of course, when we go forward and also follow the increased market interest, we get to the larger projects and we increase the size of the systems that we are involved with. So on the one hand, we're working with liquid hydrogen and PAM fuel cell systems. So for instance, the 3 megawatt systems for the Havila coastal route in Norway. But in these projects, we are merely R&D partners where you have other suppliers. So it's Ballard who is more capable than us. While on our own development, our approach is to develop systems that are more fuel flexible, and the approach is to minimize the risk for end users of selecting the one fuel of the future. So I wanted to end my presentation with just this very exciting project that we have now called the SHIP EFSA project, funded by the European Fuel Cell and Hydrogen Joint Undertaking, where we are developing and testing and installation and operation of a 2 megawatt ammonia-fueled solid oxide fuel cell systems for Eidesvik Viking Energy platform supply vessels. So in this project, we work with a number of very exciting companies and R&D institutions, cluster companies, and using, of course, green ammonia produced by Yara in this project. So I'll leave it with that, and I'm happy to receive questions afterwards. Yeah, back to you, Edwin.
Thank you very much indeed, Java. Those questions do keep coming. Please continue in that spirit, audience, because as you know, we will cover as many of them as we possibly can. At this point in time, I invite Christina to share her presentation. Christina, the floor is yours.
Thank you very much. I'm Christina, and I have worked with business development at Ballard for over 5 years now. Ballard is a component and system supplier of fuel cell systems for marine applications. We are currently involved in 5 European vessel projects in Norway, in Scotland, in Denmark, Germany, and France. Today, I will address some of the key operational challenges for fuel cells on ships, and particularly deep dive on service and maintenance. So about the operational challenges. With the new and fuel cell electric hybrid powertrains coming up, the shift from combustion technology to electrification is particularly impactful to all the people who either design the vessels, build the vessels, operate and service vessels and equipment. The technology is comparatively new and therefore requires new skills and a new set of attention, because the fuel cell systems on board behave quite differently than normal diesel engines would do, actually in most ways. Less noise and less vibration, but also a different safety setup and completely different indicators of possible errors. And adapting new technology like this poses therefore a risk to the operator and the service people. We have been in the business of servicing heavy-duty vehicles for over 15 years now. Vehicles with fuel cells, mainly buses, trucks and trains. And we therefore believe by now we have a pretty good idea about what is to expect it also from fuel cell service in the maritime market, knowing obviously that these two segments are not easily compared. But the key here is that a good service setup, a good training package for service technicians and operators, a good logistical setup of spare parts, and a good repair facility in the neighborhood are good preconditions for a successful first introduction of this new technology. In addition to that, the monitoring and control system for fuel cells is key. Based on this experience, we are today comfortable to say that the cost element for service and maintenance for fuel cell vessels will, over time, be the same level, if not less, than for diesel vessels. Here in the beginning, when introducing this new technology on board, it will start up a bit more expensive, but reducing to a much lower level. Key to a successful operation of the fuel cell system on ship is the good integration of the fuel cell system control with the vessel control system. Data and information is key to make the right decisions for the operator. We are currently monitoring about 600 fuel cell systems in commercial operation in the field, that being both stationary and motive systems. And the log files and reports created provide a good state of health impression of your fuel cell systems to the operator. They are shared with the operator and service technicians, and it helps prioritize the next service activities or the immediate action needed. Sharing data and working together on troubleshooting or providing service is a very efficient way to maintain the long life and high reliability of a fuel cell. And it also increases the learning and the understanding of this new technology, the fuel cells, for both the operators and the service team. So basically, these are the three immediate key points I would like you to take with you. I hope it gave you a bit of understanding of the operational challenges on the service and maintenance side. And I also hope I gave you an immediate impression that they are solvable and that there are good solutions out there. Thank you very much. I look forward to the interesting questions coming up. And now back to you, Edwin.
Thank you very much indeed. Great job, Stina. You've continued in the same vein as your co-presenters in that you've generated a lot of questions. So Joe, Christina, Chalva, who of course is on the line, do stand by. Just ahead of those questions, what I'd like to do is come to our audience with a poll or three. So stand by, audience. As you know, you respond to the polls by clicking using your cursor in the circle next to the particular answer that speaks to you. So here, ladies and gentlemen, should be the first poll. What is your main concern when it comes to adopting new power technology? You've got a range of options in front of you. I appreciate you can't see the voting live. I can, and I share the results in an article after the webinar. But what I can tell you is that the majority of you think there's a lack of transparency. Next up, the technology matching performance. 23% talk about in-service durability, and 19% talk about safety. Fascinating results. Let's do another poll. So do stand by. We're getting nicely warmed up. So here we go. The question is as follows. How would you grade your organization's ability to take on new power technology such as fuel cells? Once again, a range of options. This time it's on a scale of 1 to 5, with 1 representing we're light years away, 5 we're ready, willing and able, and obviously it's graduated 2, 3 and 4. What I can tell you is that there's a majority for 5, but it's very close between 4 and 5, and then it staircases back to 1, which is about 11, 12%. Full results in an article after the webinar. Just one more as I'm on a roll, and then I promise we will come to those all important questions. So do stand by, dear panel. Audience, which of the following do you see as the largest obstacle to adoption of hydrogen? Once again, a range of options. Is it price? Is it technology readiness? Is it incumbent energy industries? Is it education of regulators, legislators, and so on? Or is it other technology solutions? Well, the overwhelming majority, we're talking 70% plus at the moment, are advocating that it is price and availability. Full results in an article after the webinar. So, ladies and gentlemen, we now come to our questions. So I invite our panelists to stand by for the very first one. It's a good one, so I will read it out for you. Here we go. So the question states as follows. Standard electrical protection normally relies on the sources to produce high currents under short circuit fault conditions. The fuel cell appears to be able to produce a high current for a very limited time. Is this long enough for conventional protection and discrimination? If not, what protection can be used? So who would like to go for that first? Joe, Christina, or Charlotte on the line? Joe, would you like to give it a whirl? Come in, Joe.
Yeah, sure. I'll try to answer that just based on our experience. So there are two sides to this. One is what does the regulator want to see? What does the flag state or class society want to see in terms of circuit protection? This is actually not a bad thing from the fuel cell to not have these large sustainable currents. It's almost a self-protection feature, but that's not exactly what the regulators want to see. So what we found is that we can get creative with the use of circuit breakers and fuses to make sure that we have a safe electrical system.
Christina, anything to add?
Nope.
No. Chalva on the line, anything you would add to that response?
No, I don't think so.
It's very complete, isn't it? Well, let's have another question for, in fact, it is for Joe. So Joe, here we go. stand by. It goes as follows. How would you overcome the operational challenges of hydrogen fuel bunkering aspect on each side of the port due to a lack of hydrogen fuel supply demand in that area? And what is the challenge to overcome the OPEX operational viability in the long term? And last but not least, what's the hydrogen bunkering fuel cost at current supply to vessel? I promised you multi-part questions, Joe, so give it a whirl. Over to you, Joe.
Okay, well, Edwin, remind me if I forget the parts here. But so the first one is regarding the ability to supply the fuel. I think one of the important aspects to keep in mind is that marine can actually enable an entire hydrogen ecosystem because it is heavy usage and constant usage. So I would look at it as the other way around. I wouldn't say, where are we going to get the hydrogen from because we don't have much available today. I would say if you have a fleet of small vessels or even a single large vessel, then you can create that infrastructure and you can then spin that infrastructure off out of the port to start fueling things like trucks and then even getting into light duty vehicles. So that I would flip the answer of that one around. Second one, Edwin, can you remind me? I already forgot.
It is a multi-part question. What is the challenge to overcome the OPEX operational viability in the long term?
As Chalve pointed out, and we see the same thing, is fuel cost. So whatever we can do to get the hydrogen fuel down is going to help the economics of the situation. What we are projecting is a pretty constant cost of fuel today for a long time if it's produced from natural gas because it's tied to the natural gas price. But as we see more and more renewable electricity come online and the cost of that dropping even below that of any fossil fuel today, I'm very optimistic that we're going to see hydrogen costs coming down, and it's going to be renewable hydrogen that ends up being lower cost than the hydrogen produced from natural gas for that reason. So that's the biggest operational factor. And then I think the last question was about the cost of liquid hydrogen at the dock. Unfortunately, that varies based on where you are and who you're buying it from and the amount that you're purchasing. So from the map that I showed in my presentation, of course, if you're trying to get liquid hydrogen in South America, it's going to be much more expensive than if you're trying to get it, say, in Florida of the United States. Just because of the availability. So there's no single answer to that. It really depends on where you are, how much you're buying, and who you're buying it from, unfortunately.
Thank you. Do either of your co-panelists want to speak to the question Joe has fielded? Christina? For sure. Come in, Christina.
I just have a few added comments because I totally agree with Joe, and in the sense of establishing a hydrogen fuel bunkering facility in each port and maybe several, that is a challenge that will take many years to come to that point. The fact that Joe also mentioned the liquid hydrogen as sort of a portable way of bringing hydrogen to ports all over as a transported fuel, I think will bridge a lot of the on-site production of hydrogen that will eventually also come in many ports. The ports and their hydrogen consumption is such a massive will be a massive user of hydrogen, so that own production can be made feasible and viable in the ports. And until then, we can ship the liquid hydrogen can be shipped around to supply the different ports.
Thank you. Chalva, anything to add?
Well, yeah, I can just add that the good thing about hydrogen is the flexibility, and I think in the at least in early projects, one benefit is that you can start in a relatively small scale, and if you have a vessel going from A to B, it's really not difficult to get the payment of the one station that you established for that first project. But even if you expand, if you look at trucks and cars and get to this multi-use of this same infrastructure, you really get the cost down. But I will also say it's easier to start with a maritime application since you know the consumption, and you don't have to be you're not dependent on say 1,000 cars or something like that. So I really think that's the way to go. And when it comes to liquid hydrogen, there is a need for a larger collaboration and a more strategic development of the infrastructure. So we have this ongoing in Norway along the coast now to supply the liquid hydrogen for the first vessel demonstrations and also the first commercial project with the ferry going into operation next year, and also the larger vessels and high-speed vessels in the coming years. So these things will come together, and the cost will go down, no doubt about it. But it will take some time, obviously.
Thank you. Ladies and gentlemen, in the unlikely event of one or two cells going bad, for example, if there was a sudden mechanical failure in the MEA or cracking of a graphite plate, how do you stop the internal leakages operationally and provide an on-site solution where cell replacement is not possible? Good question. Joe, how would you deal with that? Christine will come to you in a mo. Come in, Joe.
I would deal with it by calling Christina.
Well,
I would pick up the phone and say, Joe, we would not start replacing any cells on the vessel. We would take out the entire fuel cell module and replace it with a spare part module, plug and play, and then we would take back the damaged fuel cell on land, take it to a repair shop, and there do the necessary repairs. Most vessel fuel cell systems consist of a larger number of fuel cell modules. So to take out one module for repair, replace it, does not have the major impact on the overall performance of the whole system. But no, we would never start taking the fuel cell apart on board the vessel.
Anything to add, Chalva?
No, I think it's covered by Ballard.
Perfect. So here's another one, panelists, do stand by. So I would ask you, hydrogen fuel storage requires a lot of volume compared with diesel. I don't think we'd argue with that. How does increased vessel size or decreased vessel capacity figure into the cost? We're talking life cycle and capital cost. Joe, I see you nodding in sage understanding, so let us come to you, sir. Come in, Joe.
Okay, I'll try to keep it brief. So before I left Sandia National Labs, where I worked before starting Golden Gate Zero, we did a study that looked at the limits of putting hydrogen fuel cells on vessels of many different sizes, looking only at the available space within the current engine room and fuel storage, and found that for all but one vessel, which was actually a really small fast ferry catamaran, for all the other vessels, even the largest container ships, you could fit the required fuel cell power and liquid hydrogen storage to enable that vessel to meet its voyages. So in some cases, you're not having to decrease your cargo handling capacity or increase the size of the vessel. The other thing to keep in mind with liquid hydrogen systems, especially when you're talking about lots and lots of fuel on board, is they can actually end up being lighter overall because of the density of hydrogen, the energy density there, which means if you have a displacement limited cargo ship, you can end up putting more containers on board, not less.
Thank you. Christina, anything to add?
I totally agree.
Chalva?
Yeah, I totally agree as well. Of course, it's a lower energy density with hydrogen compared to diesel, but there are also benefits, especially looking at the modularity of the fuel cell systems. You can design engine rooms in a completely different way, and although it's a challenge with the energy density, as Joe says, it's probably solvable, and also you have some benefits as well. So.
How do you manage rapid and instant power demand with fuel cells, for instance, in a tugboat application where power is needed on demand? Please, Christina, why not? Yes.
Yeah, so what we normally see is to make a hybrid power system with a fuel cell and a battery in a hybrid constellation. So, or maybe even a supercapacitor, but fuel cell plus battery seems to be the perfect mix of two technologies to both have a very impactful, powerful acceleration speed and a long-lasting, long-range power supply to the electric system.
Thank you. A lot of interest in the potential or otherwise of liquid organic hydrogen carriers. This is going to be our penultimate question. What does the panel think about the role of the liquid organic hydrogen carrier? Is it going to be something that sees the light of day? Will it be a player in the predicted hydrogen economy? What are your thoughts? Joe, then Christina, then Chalva.
Yeah, I think LOHCs have a lot of potential because of their ease of handling compared to liquid hydrogen. You can use conventional tanks on board. You know, we just need to see the technology be developed to the point where you can solve the issues of how much volume the dehydrogenation system takes up on board the vessel. And the amount of energy required for the dehydrogenation. You use a lot of hydrogen just to heat up the fluid to get out the hydrogen. So it's an area we're keeping a really close eye on, and I hope that it becomes effective in the next 5 to 10 years.
Thank you. Christina, please.
Yeah, I agree with the time horizon here. I see there's a great potential in it. We see a lot of research about it going on, very important research, and please do keep it up. It's not around the corner. There are currently still some challenges with weight, efficiency, cost, etc. So it's certainly worth keeping an eye out for it. And while we're waiting, we will use the existing solutions for gaseous or liquid hydrogen.
Thank you. Chalva, do come in.
Yeah, there are clear benefits of LOHC, both in terms of energy density of the fuel itself, and also, of course, it's stored in atmospheric pressure and ambient temperature at a liquid state. So I believe for especially the large energy demands where you have to operate for a long time, where the fuel tanks are relatively large compared to how fast you have to fill it or how fast you have to empty it, the larger the benefit of this technology. I also see some potential benefits using the heat from the fuel cells to get rid of to get the hydrogen out of the LOHC. So there are some potential of this storage types.
Edwin, if I may add one more thing real quick here, it's that before people get nervous and saying, well, why would I invest in liquid hydrogen if LOHCs is right around the corner? The fuel cell on board doesn't care. So you might need to replace the types of tanks you have on board, but in this case, you'd be going to something easier than you already have. It's not going to mean that you are going to have to get a new ship.
Thank you. Last question before a couple of polls, and then we'll come to our panelists for their key findings and takeaways, and we'll go in reverse order. So Chalva, I'd like you to take this one first, then Christina, then Joe. Currently, the lifetime of a fuel cell is said to be approximately 30,000 hours. How quickly do you expect this to develop when looking 2, 5, and 10 years ahead? Need your answers to be fairly pointed, but you're first up, Chalva. Come in.
Yeah, I think the lifetime of the fuel cells will very rapidly increase fast, and today 30,000 hours is quite a lot, but I think in relatively short time, as you get the first demonstrations and with the maritime operational, how you operate the maritime fuel cells, I think you can quickly go to 50,000 hours, and I think also you will go to 100,000 hours in not so long, especially related to the hydrogen PEM fuel cells.
Thank you. Christina, please.
Yeah, I have maybe a little bit different opinion on this point. We talk to a lot of the marine partners who are investigating this fuel cell business. What they say is they need fuel cells to last enough to live between the major overhauls of the vessels in general. We can develop fuel cells that last 40, 50, 60, 80, 100,000 hours, but they will be extremely costly. So this is a balance between a cost of the fuel cell product and the lifetime. And the main customers say to us that they need to replace a lot of the vessel components anyway every 7 to 9 years when they have a general overhaul. So they want the fuel cell to last for exactly that and not necessarily longer than that. And so our main design is really to go for these intervals of general overhauls and count on replacing the equipment then.
Thank you.
To optimize cost, basically.
I don't have anything to add, Edwin.
Nothing to add. Well, we will be coming to you, Joe, first when we invite our panelists to share their key findings and takeaways. But just ahead of that, I'm going to go back to our audience, so stand by audience for some more polls. Here's a good one for you. When, in your personal opinion, do you believe hydrogen will play a major role in the global energy economy? It nicely segues from the question we've just tackled. You can see a range of options on your screen. Click the one that makes most sense to you. The overwhelming majority, I'm talking 70%, believe that it will happen in 20 years or sooner, which undoubtedly is a relief for our panelists, I'm sure. The remainder tend to be on the 30 years or 40 years, but no one is envisaging it will be 50 years or more than that. So encouraging signs. Let's do another poll ever so quickly. Again, it's a time-based one. In the next 10 years, what applications do you think hydrogen will have the biggest impact? Where will hydrogen have the biggest impact? Again, a range of options. Will it be energy production, aviation, heavy duty vehicles, on land or maritime, or just light duty vehicles? Well, as you know, we share the full results in a poll after the webinar, but it's neck and neck between energy production storage and heavy duty vehicles on land. For our maritime interest, it's about 22% heavy duty vehicles. I'll sneak in one more and then I promise to come to our panelists in the order that they presented. And again, it's another personal opinion. In your personal opinion, audience, which of the following fuels carry the least risk when it comes to safety? So you have the options of ammonia, hydrogen, and LNG. So another one of phrasing that question is, which is the safest fuel, basically? And to your mind, 45% are saying LNG, 39% are saying hydrogen, the balance ammonia. Full results in an article after the webinar. Right, high time we heard from our panelists again. It's time for their key thoughts, their key takeaways and conclusions. Joe, you're first up. Joe, please share with us your findings.
Sure. So 2 quick takeaways I got from the presentations and also from the questions. One is that the technology is ready, it's available. These things can all be installed today on a vessel. So there's obviously research and development to make things better, but it's not a requirement to get it installed and operational. The next thing is the hydrogen usage by Maritime can enable establishment of an entire hydrogen ecosystem in a region. So I think it should be looked at as Maritime being an enabler for hydrogen, for the hydrogen energy economy.
Thank you. Let us now come to Chalva on the line. Please come in, Chalva.
Yeah, so my key takeaway is that today we have been discussing challenges, but not showstoppers. I really believe that this technology has a way forward, and I think it will go faster than maybe people will expect. And I think that you will have rapid cost decline, and as we have been talking, the fuel cost is the major part to take down. I also have to say that I think when ship owners are considering what technologies they are going to implement in the coming years, I believe the biggest risk takers are those who doesn't do anything at all. So the technology is ready, but it will be constantly improving over the next year. So, but I'm convinced that it will be solved.
Thank you. Christina, please.
Yeah, some of my takeaways from these questions and the panel discussions were that there wasn't really much question as to the performance and functionality of the technology in questions. With a chat is a success. To me, it is. The questions regarding the hydrogen availability and the bunkering facility and challenges locally also caught my ear, that I believe the usage of liquid hydrogen as sort of a hydrogen supply market-wise in different ports and harbors will be a good solution for that. And also a local hydrogen production facility in ports can be justified by the demand of the equipment and the vessels in the ports to carry an entire own production-based infrastructure locally.
Thank you. Well, I'm confident, courtesy of Joe, Chalva and Christina, we all have takeaways of significant value. So my sincere thanks to all three. Ladies and gentlemen, this has been Fuel Cells Key Operational Challenges. Next, I have an entirely new themed week starting on the 8th of June. It takes as its overarching theme offshore wind, and we kick off with a look at walk to work and rising to the challenge. Should you wish to have a complete overview of Riviera's evolving webinar program, please visit the dedicated website, which is www.riviera.mm.com/webinars. Riviera, for its part, will continue to serve the information that matters to you. We will do it through our weekly newsletters, through magazines, through curated content online that matches your interest, and through relevant events such as this. The key thing for you, audience, is that don't miss out. So for an investment of 30 seconds of your time, and by visiting our Riviera homepage and registering, you will ensure that you don't miss out on all the key news and events that impact your sector. Well, ladies and gentlemen, more than enough from me. Safe to say thank you again to Joe, Chalva and Christina for their participation. My thanks to you for coming from near and far and for your challenging and varied questions. All that remains is for you to complete the survey. You'll find it in the messenger. Please do that and we will send you the presentations and recording by return. Ladies and gentlemen, it's been an absolute pleasure spending the last 45 minutes in your company. From myself and the panel, please stay well, stay safe. Good morning, good afternoon, good evening, and for now, bye.